Okay, special right triangles. We have two different kinds of special right triangles. One special right triangle is called 45, 45, 90 triangle theorem. 45, 45, 90. That is a 90-degree right triangle with the other two angles being what degree? Take a guess from the description. 45. So both of these angles are 45 degrees, and this is a right angle. What kind of triangle is this? A what? A right triangle? What kind of right triangle is it? It's very special. What kind of right triangle is it? You don't know what I'm getting at. What happens if both angles are exactly the same here? If I turned it this way. What kind of triangle is it? Angles are the same here. Yes, it is an isosceles triangle, so that means they're on. Right triangle. Isosceles right triangle is always a 45, 45, 90. In this isosceles triangle, we have to know a pattern that always occurs. I can have this isosceles right triangle, or I can have this isosceles right triangle. No matter what, the same ratio happens when you put when you compare the side lengths or the legs with the hypotenuse. The hypotenuse is always going to be some number multiplied by a radical 2. The hypotenuse is always some number multiplied by a radical 2. And then the two other sides, what can we say about both of these sides? They're congruent. So the two other sides, we're going to call those lengths x. So if I know the length of the congruent sides, I can find the length of the hypotenuse by taking this number multiplied by square root of 2. So we memorize this because these three lengths are very easy to figure out. Now, because of memorization, we have sometimes it's helpful to have like little sayings or tricks to help you memorize. So I call this side the hypotenuse. Oops. Noose. Get it? Well, it doesn't look like the word two very much. The hypotenuse. Get it? Because my hypotenuse is x radical 2. So I got to remember that. Hypotenuse. Okay? The second special right triangle, there's only two special right triangles. So the second special right triangle is called a 30, 60, 90. It is called a 30, 60, 90 because, well, one of the angles is 90, hence right triangle. One of the angles is 30, and the other angle is 60. It is a 30, 60, 90. That has no special extra name. It's just a 30, 60, 90. I'm going to draw it a little bit bigger so I can label something. This has some formulas with it as well. There's three sides. All three sides are different lengths because all three angles are different angle measurements. So we've got three different side lengths. 3 different side lengths. Out of these 3 different side lengths, we're going to pick one of them to be x. And I'm going to choose the shortest side to be x. Depending on how good I draw my picture, you may or may not be able to find the shortest side. Shortest side is always opposite 30 degrees. Remember, the smaller the angle across from it, it's going to determine how big the side is. So my smallest angle is 30. Opposite that is going to be my shortest side. I'm going to call the shortest side x. So this could be any number. Could be any number. But what's really awesome is if I know this one side length, I can tell you the hypotenuse is 2x. So the shortest side, if it's x, then the hypotenuse is 2x. Again, it's the hypotenuse. Hit it? 2. See, they both have a 2 in them. Different kind of 2's, but they both have a 2 in them on the hypotenuse. The third side of this 30, 60, 90, the one that is across from the 60, it is the medium length side. The third side is x multiplied by a radical or square root 3. The third side is x square root 3. So if I know the shorter side, I can find the hypotenuse and I can find that medium side right away. Now, how can I remember this one? So the hypotenuse is the longest side. The hypotenuse has the 2 in it. There's 3 different sides. There's 3 different lengths. So I've got a 1x, a 2x, and I don't have a 3x, but I have an x radical 3. But that's kind of like a 1, 2, 3. Out of these 2, both of them only have 1 radical, only have 1 square root. You guys, I keep saying radical because they say it all the time, but that just means square root. So I don't want to be confusing anybody. But both of these only have 1 square root. The one that has 2 different side lengths has the square root 2. The one that has 3 different side lengths has the square root 3. So I'm just trying to give you ideas of how you can memorize these. The one with 3 different side lengths has the square root of 3. Do either of these have 2 square roots in the triangles? No. Okay, so we're going to use this information. We're going to find the value of x. So here we are. What kind of triangle is this? Is it 45, 45, 90, or is it 30, 60, 90? 45, 45, 90. So the rules for 45, 45, 90 are x, x, and then x radical 2. So right now, I know that x is 11. If I'm using my rules, x is 11. We have to find, it looks like the hypotenuse. I now wish I had not used x's for my formulas because there's an x here. This can be any variable. I'm getting rid of it because it's confusing. We're going to find the hypotenuse, okay? So I've got my 1x, x radical 2. If I know that x is 11, how do I find my hypotenuse? I know x is 11. How do I find this answer? John? So x is 11. Oops. We're going to substitute 11 in x square root 2, and guess what we get? 11 square root 2. That's it. That's all I have to do. Just put it right there. That's all. I did not have to do Pythagorean theorem. That was it. Here's the next one. This is what kind of triangle? 45, 45, 90 or 30, 60, 90? How can you tell there's no measurements? Because there's two of the congruent sides and it's 90, it has to be a 45, 45, 90. So we look at our formulas. These two sides are x, and then this one is x square root 2. I need to find the x side. I need to find the short side. So I know that x square root 2 is the same side as 2 square root 6. I know that x square root 2 and 2 are the same. So I'm going to solve this equation for x. How do I get x by itself? Raylan, what is going on here between x and a radical 2? What operation is that? If they're next to each other with no symbols, what operation? Abstract, multiply, divide. Can't hear you. Multiplication. So how do I undo multiply by square root of 2? I'm going to divide both sides by square root 2. Because we're undoing multiply by square root 2 and I divide by square root 2, these undo each other and we get x. On the other side, we're going to simplify this. If I take a square root of 6 and I divide by a square root of 2, they're both square roots. You're allowed to divide them. If they're both square roots, you're allowed to divide them. If they're both square roots, you can divide them. So what is square root 6 divided by square root 2? Everybody know? Take a guess. What, Cameron? Yep. So we get 2 square root 3 as our answer. These sides are 2 square root 3. Okay. Find the value of x. What kind of triangle is it? Jesse, what kind of triangle is this? The isosceles right triangle, which is what angles? The 2 of the 45 degrees is the 90. Yep, 45, 90. 45, 45, 90 degree triangle. Okay. So the formula is x radical 2. That's my formula. X radical 2. We have to find what? X. So the x radical 2 side is equal to the 9 radical 2 side. Stephen, if x radical 2 equals 9 radical 2, can you tell me what x is? What? Okay, divide by square root 2. X equals 9. Perfect. So those two sides would be 9, 9, and then we've got 9 radical 2. Number 2, we've got, what kind of triangle is this? Number 2, what kind of triangle is this? Aaron, what kind of triangle do I have for number 2? Right, because this is isosceles. We haven't seen the other kind yet. So we need to find the hypotenuse. We need to find the hypotenuse. So ignore the fact that it's an x right now. This is our x side. And the hypotenuse is x radical 2. I already know what x is. X is 15 radical 2. So I put that in the x place. I substitute. So in my x spot, I'm going to have 15 square root 2. And then outside of my x spot, I have another square root 2. Did I lose you here? This is x square root 2. So then the question is, how do we multiply a square root of 2 times a square root of 2? We did this already. How do we multiply a square root of 2 times square root of 2? Lynn, you know? Say it again. It will just be 2, yeah. What did you do in your head to get it? Squared it. Is that what you were saying? I just couldn't hear you. Yeah, so she said, well, 15 times square root of 2 squared is just 15 times 2. So our hypotenuse is 30. Okay, number 3 is a 45, 45, 90, because I see the 45, I see the 90, so this one has to be 45. Jay, which side am I trying to find? Am I trying to find one of the legs, or am I trying to find the hypotenuse? Which side? The hypotenuse. And we know that the formula for the hypotenuse is x square root 2. The other two sides have what formula? Ryan, what are the formulas for these two sides? Okay, what's the formula for them? Yep. So if I know that x is 25, and I need to find the hypotenuse of x radical 2, Maggie, can you help me? And that's it. And that's it. Okay. This one is an equilateral triangle. So we've got an equilateral triangle. All three sides are equal. And we're going to find the height of this equilateral triangle. This I'd say we use it a lot for. If we have an equilateral triangle, we're going to find the height, the altitude. If we have an equilateral triangle, what are all three angles in an equilateral? They are equal. What are they? 60. They're all 60s. So when I draw that height and I drop it down, because this, when I drop it down, this is like an it is an isosceles triangle. When I drop it down, each corner is 60. It's going to divide the top into 30s. And we're going to have a 30, 60, 90. Okay? This says the equilateral triangle has side lengths of 6 square root 3. So you can see in this picture 6 square root 3, 6 square root 3. Down here was 6 square root 3. We just divided it into two pieces. We're going to find the height of this. So I'm going to redraw kind of what I'm looking at here. To find the height, which I'll call H, we've got a 60 degree here, and we've got a 30 degree here. We know that 6 square root 3 is this length, and we know that 3 square root 3 is this length. So this is the 30, 60, 90 example. Across from 30 is always the short side. What's my formula for across from 30? If you need to look back. There's 3 different side lengths. This is a 1, 2, 3 triangle. Across from 30 is which formula? We already wrote it at the beginning. Yep. The shortest side is always the x. In both triangles, the shortest side is the x. Now, this is the 1, 2, 3 triangle. Which side has the 2 in it? Which side has the 2 in it? The hypotenuse has the 2 in it. But for 30, 60, 90, it is not a radical 2. 30, 60, 90, it's just, oh no, okay. It's just 2 times the short side. So this one has 3 different sides. What am I still missing for my formulas? It has 3 different sides. It's a 1, 2, 3 triangle. John? Yeah, formula, go. Formula. Right. So this one's going to be x square root 3. So there's my 1x, my 2x, and my 3x, but it's x square root 3. There's only one square root in the whole triangle, and this is the triangle with the square root 3. I'm just trying to give you h. Do we know x? Do we know x? Yes or no? It's going to take forever. David, do we know x?
I don't think so.
I wrote an x somewhere.
Oh, is it 30?
So 6 square root 3 is 2x. I could find x, but I should already know x. It's 3 square root 3. So we're going to substitute. So I'm going to have 3 square root 3. That's my x. And then I have multiplied by another square root 3. I'll multiply that out. So I'm going to have 3, and then what do I do to multiply square root of 3 times square root of 3? I will have square root of 3 squared, because there's 2 of them. And because I have square root 3 squared, that becomes 3. So our height is 9. Excuse me. All right, next one, 30, 60, 90. I know it's 30, 60, 90 because I can see the numbers. 30, 60, 90. Across from the 30 degrees is always the shortest side. So you want to look for the 30 first. What is the formula for the shortest side in a 30, 60, 90? Denise, what's the formula for the shortest side? X. Perfect. And it's already an X, even better. This is a 1, 2, 3 triangle. Ryan, what's the formula for the hypotenuse? 2x. That leaves us with one more side. The formula for the third side. Avneet. X square root 3. Now I look at these 3 sides. There's only one side that I have revealed to me. It's this one right here. I know the x square root 3 side. I know the x squared of 3 side is equal to 4 square root 3. I know that. I'm saying it out loud and I'm writing down in math what I said. I know the x square root 3 side equals 4 square root 3. How do I find the x? Rakaya, what do I do this equation to this equation to get x by itself? Perfect. So I get x equals, that will cancel, and it cancels on the other side also, 4. So we have x equals 4. Now we got to get the hypotenuse. The hypotenuse says 2 times x. And what is x? 4. So what's my hypotenuse? 8. This will always be true in a 30, 60, 90 is the hypotenuse is 2 times the length of the short side. Always and forever. That's always true. That's why it's special. So here we have an equilateral triangle that has side lengths of 24. What's the height of this triangle? We have an equilateral triangle, side lengths 24. We want to know the height. If the side lengths are 24, I can break apart the bottom into 12 and 12. What are these bottom angles? If it's equilateral, what are they, Erin? 60, yeah. So we have 30, 60, 90 degree triangles, meaning this one up here is going to be 30. Look how the side, bless you, side across from the 30 degrees is 12. That's our x. The hypotenuse of this triangle is 24. That's our 2x. See how they're twice each other? We need to find the height. Emily, what is my formula in the 30, 60, 90 for the third side? Well, it's written right above in red if you don't want to scroll back on yours. The formula for the third side. I've got my x already. I've got my 2x. What's the third side? Can you say a little bit louder? I wrote it in red here. So you see the x and the 2x. And then down here I have the x in blue and the 2x in blue. I need to find this formula with x's. Well, what's the one I didn't repeat up here? Okay, so the 12 down here is our shortest side, which we're going to call x every time. Okay? And our hypotenuse is always 2x every single time. The third side, we always say, is x radical 3. So I'm like trying to reinforce that it's a 3, but I keep calling it the third side. So your answer to me is going to be x radical 3. X radical 3. When we have a equilateral triangle, the height is always going to be x radical 3. Always. Because with an equilateral triangle, it's always a 30, 60, 90. So if I'm doing x radical 3, what am I plugging in for x? 12. So height equals 12 radical 3. Done. Here's another one, just like it. Well, kind of like it. We've got an equilateral triangle, which makes these 60s at the bottom. This is telling me that my height is 13 radical 3. That's my height, 13 radical 3. I'll write it again over here, just the blue triangle. I'm going to put my formulas in a different color. I'm going to put my formulas in a different color. Cameron, across from 30 degrees is which formula? Yes, I didn't hear you, sorry. X. The hypotenuse, Matthew, the hypotenuse is, I'm not asking the answer. Formula. 2x. And then that makes the third side, Raylan, what's the third side? X radical 3. Now looking at these three, I know the third side. That's the one I know. I know that x radical 3 is 13 radical 3. So we divide by radical 3. And we get that x equals 13. What am I supposed to do? What are the side lengths of the triangle? So what would 2x be? Alex, what's 2x going to be? 26. So what's the answer? What are the side lengths of the triangle? Is the answer 13, 26, 3 radical 3, or x radical 3, 13 radical 3, I mean? What's the answer for this one? Lynn, what do you think? 26 is the only answer because they're asking about the original equilateral triangle, which has 26, 26, and okay, look at this one, 30, 60, 90. Across from 30 is which formula? Across from 30 is x. The hypotenuse across from 90 is J. 2x. Good. And J, help me one more time. What's the third side? Perfect. X squared 3. Ignore the fact they have an x there. That's just telling us what side we're going to find. So across from 30 is 7 square root 3. That is the x. We need to find the x square root 3 side. So we're going to substitute 7 square root 3 into that square root 3 equation. So 7 times square root of 3 squared is 7 times 3, which is 21. Okay, Jesse, number 7. I found my 30 degrees. What formula goes across from 30?
2x.
Hypotenuse, right? So what goes across from 30?
So it would be the x squared.
Okay. The 30 degrees is the smallest angle. So the smallest side goes across from 30 degrees. And in the 30, 60, 90, the smallest side is the one that's just a variable by itself. So what goes here? Just x. That's why I start there every single time. I start with a 30 every single time because that one's going to be just x. Okay, now, Jesse, the hypotenuse, if I know that this is x, the hypotenuse is what formula?
X I keep mixing them.
I know. 2x. And lots of people are going to mix them up, and that's why we got to memorize these. And then the third side, Jesse, the third side is going to be which formula?
The one I just said.
Say it.
The x squared.
Nope. The third side is going to be x square root 3. We use the square root 2 in the 45, 45, 90. So what's x in, not the answer x, but what is my x? If we've got 5 square root 3 is equal to x square root 3, what's x? Yell it out. 5. Good. So this is 5. We have to find the hypotenuse. What's the hypotenuse? What's the answer? 10. Thank you. You guys are quiet, and I can't tell if you don't get it or you're just being quiet. Last one. Alexa, we're going to always start with the 30 degrees. What is the formula across from 30 degrees? X. Good. So I already know that x is 31. Emily, what is the hypotenuse formula? Mm-hmm. So if I know that x is 31 and I need to find 2x, I need to find 2 times 31, we get 62. All right, so I told you earlier your assignment is on Canvas, but you got to do it on your own paper because I was going to print it, but it was going to take way too much paper. You can do it on the computer if you're going to print it out. Who asked that? Maggie? Was that you, Maggie? Yeah. So because I want to have it in my hand.